So we have learned about the equilibrium yesterday. We can see that there is a process of diffusion going on. What happening? The, can you see this thing that the molecules of the gases in the reactant side on one side is maximum, where other side is empty, right? So when the diffusion start, what happened? At one stage, the equilibrium gets established. Okay, means that number of moles at one side will become equal to the number of moles on the another side. Okay, so this is the state of equilibrium when the number of moles of one component or the reactant will become equal to the number of moles on the product side. Okay, so general characteristics of equilibrium involving in physical process. So we know this thing that when we perform any reaction, so we can see it physically. We don't know the chemical changes or whatever things are going on chemically in a reaction. Okay, so equilibrium is only possible only in a closed system at a given temperature. And we know this thing, to perform an experiment, we have to take a fixed temperature. So equilibrium can only be possible in a closed system where nothing is going, where nothing can exchange in the system, okay, at a given temperature. Secondly, both the opposing processes occur at the same rate and there is a dynamic but a stable condition. Okay, both the opposite processes means forward direction or reversible direction will means the rate of reactant and the rate of product will become equal. Okay, and that is a stable condition, means there is a dynamic equilibrium. So when equilibrium is attained for a physical process, it is characterized by constant value of one of its parameters at a given temperature. So the magnitude of such quantities at a given stage indicates the extent to which the physical process has processed before it reached the equilibrium. Correct. So now we'll talk about the dynamic equilibrium. Previously, we started that what is dynamic equilibrium, what is this, and how it gets established and how it gets changed. So let's just talk about the dynamic equilibrium now. So in general case, dynamic equilibrium is established when the rate of forward direction and the rate of backward direction will become equal. Means when A or B combines together, they form C and D, and the vice versa, will from C and D, A B will be formed. Okay. So with the passage of time, there is accumulation of the product C and D and depletion of the reactant A and B. This led to the decrease in the rate of forward direction and increase in the rate of the reaction. Okay. So finally, two reactions occur at the same time and the system reaches to the state of equilibrium. And that is known as the dynamic equilibrium. As you can see this thing, that initially when reactions start, what happens? The product will not form, means they are indicating that we just initially starting the reaction and we have the amount of reactant here. So when you see that the reaction moves forward to the right or its start completion, then to form the product. Okay, so note the total number of molecules here. That means that reaction as process and product have formed after combining the reactants. Okay, so the reactions move to the left. When the reaction get reversed, what happened? To reform the reactions, note the total number of molecules. 3 molecules here and 5 molecules are here. So what happened? When the reaction is in dynamic equilibrium, there is a difference in the number of moles. You can see that 2 moles in the reactant side and these 6 moles are on the product side. So simultaneously this will go on continuously whenever these two combine together and it gets reversed. So this is a state of dynamic equilibrium. Correct? Law of chemical equation and equilibrium constant. So now we'll talk about the law of chemical equation. We know that in a reversible reaction, what happens? The reactants combine to form the product. So these reactant and product are balanced. Hence, we can relate them in an equilibrium equation, that is Kc is equal to Cd upon AB, and that too in the big bracket, where Kc is called the equilibrium constant and the expression on the right side is known as the equilibrium constant expression. So this is known as the equilibrium constant expression and Kc is the equilibrium constant. So at a given temperature, the product of the concentration of reaction product raised to the respective stoichiometric coefficients in the balance equation divided by the product of the concentration of the reactant raised to their individual stoichiometric coefficient has a constant value. This is known as the law of chemical equilibrium. What happens? Means when you just perform an experiment, so you have to balance it first. For example, if you are adding 1 mole of one thing and 2 mole of another thing, then you will balance that thing with the number of moles whatever they form after the reaction. So for example, I have a reaction. I took a number of a substance, b number of b substance, and led to form c number of c substance and d number of d substance. So at this time, what how I have to write this equation? I will write this equation like this: Kc is equal to c की power c, d की power d, and a is the power of A and B is the power of B. And these small c, d and a, b just represent what? They just represent the number of moles, the stoichiometric coefficients. Or we can say that whatever number you see whenever you balance the reaction before the symbol of your compound or the atom, you will raise it as the power of that around just above the big bracket. So this is the representation of equilibrium constant, where A and B are combining with the C and D with the moles of small a, small b, C and D. Okay, so we know this thing that the formula of Kc is the product upon the concentration of reactant. So C is the power of C, small d is the power of D, a small a is the power of capital A, and B is the small power of capital B. So equilibrium constant for reversible reaction is the inverse of equilibrium constant in the forward direction. And whenever you just reverse this reaction, you just reverse the entire formula. At that time, the reaction will become different. How? The reactants will become product and the products will become the reactant. Okay. So this is the speed. Means whenever the reaction is going on, whatever, how many number of product will form will be equal to the number of product. So whenever the reaction is in forward direction, this will be like this. And when the reaction will be in backward direction, what happens? It's just it vice versa of that. Okay. This formula or this reaction is also known as the law of mass action, because initially when the scientists didn't know about the equilibrium constant or equilibrium equation, what happened? They just gave the concern another name to the concentration, that is mass action, means action of mass. Because whenever we perform an experiment, we are doing changing in mass. There will be a change in mass of the substances or the components which we are taking to perform the experiment. Okay, so for before the proposal of this equilibrium constant, law of equilibrium constant, this was known as the law of mass action. For this, the relationship between the equilibrium constant K and the concentration of reactant and product. Okay, the product will divided by the reactant. Okay. So what does the value of K means? We know this thing that Kc is there, but what is the meaning of K? So whenever we perform an experiment, we just react the reactants and product will form. Where if K is greater than 1, means smaller than, sorry, K is greater than 1, the reaction is product forward, means it's like product favor. When the product is maximum, means product are predominate at equilibrium. Okay, means if K is greater than 1, it means that reaction is product dominating. Okay, if the reversible vice versa process is there, what happened? That will be like this reactant dominated. Okay, if what next is if K is smaller than 1, then what happened? If K is smaller than 1 or reverse, that the reactant prominent at equilibrium. So you can see this in A, K is greater than 1, so the amount of product is greater than the amount of reactant. So we can say that this is product dominated. Okay, means where product are more as compared to the reactant. And if K is smaller than 1, then you can see this reaction is reactant predominated at equilibrium, means amount of reactants are maximum as compared to the products. Okay, so then the range of equilibrium constant will be like this. If you see the small k, it indicates that the this is reactant, this is product, means reactants are maximum and product is 1. If you see the intermediate, means the ratio between the product and reactant is equal, and if k is large, then what happens, product is maximum and reactant are, sorry, reactants is minimum and product are in large amount. So you can see the consistency. If K is small, the product will be small. If K will be intermediate, the ratio between the product and reactant will be equal. And if K is large, then the product amount is large and the reactant amount is less. Now, what is homogeneous equilibrium? So in a homogeneous system, the reactant and the product are in same phase, means solution phase. If you are taking a, compound or the reactant in gaseous phase, then all must have in gaseous phase, the product and reactant both. If you are taking the aqueous and liquid phase, so you can see, you can mix like liquid and aqueous because they both are nearly of same consistency, and when you mix an aqueous solution in liquid, you will get an aqueous solution. Okay, means homogeneous equilibrium can only establish where the product and the reactant are in same phase, whatever the liquid phase, solid phase, aqueous phase or gaseous phase. Okay, so this will be shown like this. So when you react this aqueous with liquid, then you will get what, CH3COOH in aqueous and C2H5OH in aqueous, right? Same with this Fe 3 positive aqueous with SN negative, and it's the reversible reaction. So FeSN 2 positive in aqueous. Okay, so homogeneous equilibrium can establish when the equilibrium is in the same phase, means all the components, products, and reactants are in same phase. That's the equilibrium constant in gaseous system. So whenever we talk about the gas or anything on gas, and the ideal gas equation you have to consider, means you have to consider that the ideal gas equation if we are talking about anything on gas or about gas. Okay, so we know this thing that PV is equal to nRT. This is the ideal gas equation. PV is pressure, volume, and N is number of moles, R is Rydberg constant, and T is temperature. So we can write it like this: P is equal to nRT upon V. Okay, so P is the pressure in pascals. So in when we talk about the ideal gas equation and pressure here in the equilibrium, then at this stage we just take the pressure in pascals. N is the number of moles. V, the volume is cubic meters or meter cube. We have to take the volume in meter cube. T is the temperature. We have to take the temperature in Kelvin. C is the concentration of moles per liter in P is the P is in bar. When we talk about the C, means we talk about the concentration. So concentration means moles per liter. Moles per liter means N upon V, number of moles upon volume. So we just substitute this NV is equal to C, means we just write C in place of N upon V because concentration means moles per liter. Okay, and N is moles and V is volume, means liter. So we can write here P is equal to CRT, where R is equal to 0.0381 bar liter mole Kelvin. Okay, this is the value of Rydberg constant, right? So whenever we perform the experiment, if we see that the temperature pressure is given in bar or ATM, so you have to convert it into Pascal. And if you see the temperature is given in Kelvin or Fahrenheit, then at that stage you have to convert it into bar. Okay, and whenever you see the concentration, or we are talking about the number of moles or concentration of the um, products and reactions, you can substitute this C in place of N upon V, because N upon V is equal to moles per liter, which means C is equal to concentration in moles per liter. Okay,